Hello, my name is Lemuel Urig and welcome to a video all about the Wolff-Kishner reduction. We'll also be showing you imine formation, or the formation of an imine, because that is a very important step in preparing for a Wolff-Kishner reduction, especially if your starting material is acetophenone like ours is. Acetophenone will react with hydrazine and an H+ to form the imine. Then the imine will react with NaOH and heat to perform the Wolff-Kishner reduction and create our end product of ethylbenzene. Now, the imine formation begins with H+ being attacked by the lone pair on oxygen. This forms a positive charge on oxygen, which is resonance stabilized by electrons moving up to the oxygen from the pi bond and placing the positive charge on the carbon here. Now this carbon is trigonal planar and can be attacked by hydrazine on either the top side or the bottom side. If it attacks on the top side, this methyl group will be pushed back. If it attacks on the bottom side, this methyl group will be pushed forward. Both are chiral centers and will exist in a 50-50 racemic mixture. Regardless of which formation you have, a base will attack the hydrogen on the positively charged nitrogen, returning the electrons to the nitrogen. In both cases, the mechanism is the exact same. Once this nitrogen no longer has a positive charge, we're free to continue our imine formation. The imine formation continues once again with H+ being attacked by the lone pair on oxygen. It does the same thing with the other stereoisomer. This forms a great leaving group with a positive charge on an oxygen atom and 2 hydrogens. Once this electron pair moves up and leaves with that group of atoms, we have water, which is a great leaving group. And this will react in the same way no matter which chiral orientation you have. The positive charge is now on the carbon and the species is trigonal planar once again. That positive charge is resonance stabilized by the lone pair on nitrogen, moving the positive charge to the nitrogen atom. Once again, a base will attack the hydrogen and remove it, allowing those electrons to be placed on the nitrogen, removing that positive charge, creating an even charge on the entire molecule, and creating our imine that we're then able to proceed to the Wolff-Kishner reduction. The Wolff-Kishner reduction begins with NaOH, which we know we don't draw the metal because it does not help us in this reaction. Instead, we draw a negative charge on our oxygen with 3 lone pairs. One of those lone pairs will attack a hydrogen on the terminal nitrogen, and the lone pair, and then the sigma bond will return to the nitrogen. This will create a negative charge on nitrogen that will then be resonance stabilized all the way over to the benzylic carbon. The benzylic carbon with its negative charge will then reform the catalyst, which is now in the form of water, by attacking and taking one of the hydrogens off of water. Whether this attaches to the top or the bottom will again form a 50-50 racemic mixture at this chiral site. No matter which stereoisomer you have, both of them proceed in the same way. NaOH, which was just reproduced, will now attack the second hydrogen atom on the terminal nitrogen and again create a negative charge on that nitrogen. This time, when the lone pair forms a pi bond once again, it will cause the leaving group diazine to be formed on both stereoisomers. So once again we have NaOH. It attacks the hydrogen here, moving the electrons onto the nitrogen, and then the electrons form a triple bond between both nitrogens, followed by the leaving of this diazine species. Once diazine is left, water exists, and the lone pair on carbon is then able to reform our catalyst NaOH once again and form our final leaving, or our final product, ethylbenzene. Thank you for watching, and I hope this helps.